Good day everyone, welcome back to another video lesson in Mathematics Grade 10. And for this video lesson, we will be talking about pizza. What can you see in the picture, guys? It's a big pizza, right? According to Guinness World Records, the largest pizza ever made has a total surface area of 1,261.65 square meters. So that's so big. And it was recorded in Rome, Italy on December 13, 2012. It was prepared by Duvilio Nardi and friends. The said pizza is gluten-free pizza, and it was named Octavia in honor to the first Roman Emperor Octavian Augustus. Now you know. In this video lesson, we'll be talking about sectors and segments of a circle. Now, consider this pizza. Let the outer ring of the pizza be a circle, and a slice of it is called sector of a circle. Before we start discussing about areas of sectors and segments of a circle, let us define first what is a sector and segments of a circle. So let's first start with the first slice of the pizza, which is the sector of the circle. A sector of a circle is a region bounded by two radii of the circle and their intercepted arc. In our illustration, consider circle F, and segment EF is a radius of a circle also with segment FG. So these are radii of the circle. The intercepted arc is arc EG, and the shaded region colored red is called the sector of circle F, and we name it as sector EFG. Now, let's proceed to another slice of a circle, which is segment of a circle. A segment of a circle is a region bounded by an arc and a segment that is chord joining its endpoints. Consider circle B. Segment AB and segment BC are radii of the circle. Bounded region by arc AC and chord AC is what we call segment of the circle. And we name this as segment ABC. And now, let's talk about area of a sector. The area of a sector is a fraction of the area of a circle containing the sector. Remember that the area of a circle is equal to pi r squared. And the sum of the measures of the central angle of a circle is equal to 360 degrees. So if we consider the central angle of the sector be 8 degrees, then it is just a fraction of that, of 360 degrees. So the area of the sector will be 8 degrees over 360 degrees times the area of the circle, which is pi r squared. So let's have an example. Find the area of sector ACB. In this figure, arc AB is 90 degrees, which means the measure of the central angle ACB is also equal to 90 degrees. The measure of a radius of the circle C is 6 centimeters. Remember that the area of a sector is equal to 8 degrees over 360 degrees times pi times r squared. So 8 degrees is 90 degrees over 360 degrees times pi times the radius is 6 centimeters. So 6 centimeters squared. 90 over 360 is 1/4 times pi times 6 centimeter squared is 36 square centimeters. So, simplifying, we have 36 divided by 4, that is 9 pi square centimeters, or approximately equal to 28.27 square centimeters, if we are going to round off that to 2 decimal places. Let's have another example. Find the area of sector QSR. So, consider arc QR is 45 degrees, which means QSR is also equal to 45 degrees. And then the radius of the circle is 12 centimeters. So substitute that to the formula. Area of the sector is equal to A degrees over 360 degrees times pi r squared. So that will be 45 degrees over 360 degrees times pi times r squared is 12 centimeters squared. So, 45 over 360, that is equal to 1/8, times pi times 12 squared is 144 square centimeters. So, 1/8 times pi times 144, that is equal to 18 pi square centimeters. So, that is approximately equal to 56.55 square centimeters. That is how we find the area of a sector. Now, let's proceed to the area of a segment. So the area of a segment of a circle can be determined by subtracting the area of the triangle formed by the chord and the radii from the area of the corresponding sector. So the area of a segment is equal to the area of the sector minus you subtract the area of the triangle to get the area of the sector. Okay, let's have an example. So find the area of segment ACB. Given is the intercepted arc AB, which is 60 degrees, and then the measure of the radius of circle C is 5 centimeters. So first step, first step is we are going to find the area of sector ACB. So area of this sector is equal to 60 degrees over 360 degrees times pi times the radius, it is 5 centimeters. So that is 5 centimeters squared. We have 1/6 times pi times 5 squared is 25 square centimeters. Simplifying, we have 25 pi over 6 square centimeters. Step 2, we're going to find the area of triangle ACB. So I'm going to change the color of this. So we're going to find the area of triangle ACB, that triangle. So I'm going to illustrate it here. So let's have this as ACB. So I rotated it. No? So this will become the radius. Yan yung radius ng circle natin. radii, and radii of the same circle are congruent. So that will be 5 centimeters. And the central angle is 60 degrees. And take note that if it is isosceles triangle, then the base angles are also congruent. Since 60 yan, then 180 minus 60, that is 120 divided by 2, so 60 and 60. So it will become an equilateral or equiangular triangle, and an equiangular triangle are also equilateral triangles. So the base will become 5 centimeters. If we are going to find the height of that, since the area of the triangle is equal to 1/2 base times height, we know already that the base is equal to 5 centimeters. So we have that. And the height of our triangle will be, so this angle will become 30 degrees. So our triangle, if we are going to consider this triangle, it will become a 30 degrees, 60 degrees, and then 90 degrees triangle. And in a 30, 60, 90 degrees triangle, the height is equal to the base. Ang i-consider na lang natin na base ay eto. So kapag 5 yan, this is 5 over 2. And then the height will be 5 over 2 square root of 3. So in this case, the height is 5 the square root of 3 over 2. So we simplify. So we multiply 1 times 5 times 5 the square root of 3. So that will be 25 the square root of 3 over 2 times 2, 4. So the answer is 25 the square root of 3 all over 4 square centimeters. May I change the color? Next, step 3, we're now going to find the area of segment ACB. So the area of segment ACB will be area of the segment is equal to area of the sector minus area of the triangle. So that will be 25 pi over 6 square centimeters minus 25 square root of 3 over 4 square centimeters. So that will be the answer, or that is approximately equal to, let's have 25 pi over 6 minus 25 square root of 3 over 4. And that is approximately equal to 2.26 square centimeters. Okay, that is how we find the area of the segment. Okay, let's have another example. Find the area of the segment XZY. So the measure of the arc is 135 degrees and the measure of the radius is 8 centimeters. So in this case, ganun din, find the area of the sector. Find the area of the sector XZY. So that will be area is equal to 135 degrees over 360 degrees times pi times the radius 8 centimeters squared. So 135 over 360, that is 38 times pi times 8 squared is 64 square centimeters. So simplifying, we can divide this. 64 divided by 8 is 8. 8 divided by 8, 1. So 3 times pi times 8, that is 24 pi square centimeters. Second step, find the area of triangle XZY. Notice that our triangle, so if that is 135 degrees, so this is Z, that is X, and that is Y, this is 8 and 8. It is a special triangle. If it is a 30, 60, 90 triangle, if it is a 45, 45, 90 triangle, it's really difficult for us to find the area of a triangle which is not a special triangle because our formula is 1/2 base times height. Tama ba? So, difficult sa atin yung pag-find ng height ng triangle. So, let's recall yung knowledge natin in finding the area of an oblique triangle. And we are going, since yung given natin ay sides of the triangle and their included angle, then we use the formula 1/2 times, since the two sides of the triangle are equal and it is the radius, let's use the notation r squared, and then sine theta. So our theta will be our included angle, which is 135. So area is equal to 1/2. Area of the triangle is equal to 1/2 times 8 squared sine 135 degrees. So we use our calculator, scientific calculator. So 1/2 times 8 squared is 64 times sine 135, that is equal to square root of 2 over 2. So simplifying, that is 1 times 64 times square root of 2, that is 64. I'm going to write it here. 64 square root of 2 over 2 times 2, 4. We can still simplify this one. So 64 divided by 4, that is 16 square root of 2 centimeters squared. So I forgot to write centimeters squared down. So, yeah. So 16 square root of 2 square centimeters. Step 3, we're going to find the area of segment XZY. So that will be area of the segment, that is equal to 24 pi minus 16 the square root of 2 square centimeters. So we can round off that. That is now the answer, but we can round off that to 2 decimal places. Square root of 2, that is equal to approximately equal to 52.77 square centimeters. That is how we find the area of the segment. Okay, so there are different ways on how we can find the area of the shaded region. So the first one is we consider this shaded here as a segment, right? So there will be 1, 2, and then 3, 4, 5 segments. So we multiply it by 5. Another way is that you are going to find the area of the circle, then subtract the area of the pentagon, because that is a polygon with a regular pentagon with 5 sides. So, regular kasi equal lahat yung sides ng pentagon natin. So, gamitin na lang natin yung knowledge natin on finding the area of a segment. So, first step, we're going to find the area of a segment muna. So, shinortcut ko na. So, area of the segment is equal to 8 degrees over 360 degrees times pi r squared minus 1/2 r squared sine theta. So, if you notice, eto ngayon yung area ng sector natin and this is the area of the triangle na isusubtract natin. Sir, ano yung 8 degrees na ngayon? Remember na equal lahat itong chords na to, which means congruent din yung intercepted arcs nito. So, 360 divided by 5, which means ang intercepted arc ay 72 degrees. So, the angle is also equal to 72 degrees, 72, 72, 72 degrees, 72 degrees yan. So, if you're going to add all, it is equal to 360 degrees. So, this will be 72 degrees over 360 degrees times pi times the radius, it is 5 centimeters squared, minus 1/2, the radius is 5 centimeters squared, sine theta is 72 degrees. We simplify, so we have 72 degrees over 360 degrees, that is 1/5 times pi times 5 centimeters squared, that is 25 square centimeters, minus 1/2 times 5 centimeters squared, that is 25 square centimeters. Then, sine 72 degrees, so sine 72 degrees, that is equal to 0. I-decimal na lang natin, and we use 4 decimal places to be more accurate than 2 decimal places. 9,511. Okay? So, 1/5 times pi times 25, that is equal to 5 pi. Ayan. Sige, sulat muna natin yung 5 pi. Minus, since nag-decimal na tayo doon, sige, magde-decimal na lang tayo dito. Okay? Pero we use 4 decimal places, ha? So, that will be 15.7080 minus, that is 1/2 times 25 times 0.9511. So, that is 11.8888. Subtract it from 15.7080. We have 3.8192 square centimeters. So the area of the segment, one segment is equal to 3.8192, which means we multiply it by 5, the area of the shaded region. So therefore, the area of the shaded region is 3.8192 times 5. So that will be 19.096 square centimeters. We are done with that. Now let's proceed to word problems involving sectors and segments of the circle. So a goat is tied with a 10-meter rope at the corners of 2 perpendicular walls. Find the grazing area of the goat. So we have here an illustration. So these are the perpendicular walls. So kapag perpendicular, the angle measurement is 90 degrees. And it is tied at the corner of that perpendicular wall, yung goat natin. And the measure of the rope is 10 meters. So that will become our radius of the circle. And the grazing area is a sector. So we use the formula, area of the sector is equal to A degrees over 360 degrees times pi r squared. So that will be 90 degrees over 360 degrees times pi times r squared, that is 10 meters squared. So that will be 1/4, 90 over 360, 1/4 times pi times 100 meter squared. So 100 divided by 4, that is 25 times pi, 25 pi meter squared, or approximately equal to 78.54 square meters. That's the grazing area of the goat. Very easy? Can you follow? Nice one. Now let's have another example. In Tea and Go Cafe, each of its tables is customized as illustrated at the right. So we have here an illustration of each table in the Tea and Go Cafe. The round table with a diameter of 160 centimeters can be folded to form a square table. So if the diameter is 160, therefore the radius of the circle will become 80 centimeters. If one of the draft leaf of the round table is folded, what is the area of the draft leaf if it has an arc measure of 90 degrees? So the arc measure is 90 degrees. So the central angle is also equal to 90 degrees. So we are going to find the area of a draft leaf. So isa lang. So we use our knowledge in finding the area of a segment. So yung first step natin, find the area of the sector. So since we label it as ABC, then let's find the area of sector ABC. So area of the sector is equal to 90 over 360 degrees times pi times r squared, that is 80 centimeters. So that will be 1/4 times pi times squared pala to. I forgot to write yung squared. So 80 squared, that is 6,400 square centimeters. And divided by 4, that is 1,600 pi square centimeters. So number 2, find the area of the triangle. So let's just use yung formula natin na 1/2 r squared sine theta. So that will be 1/2 80 centimeters squared sine 90 degrees. So that will be 1/2 of 80 squared, that is 6,400 square centimeters. Sine 90 is 1, so that will be 3,200 square centimeters. And then, step 3, find the area of the segment. So the area is equal to 1,600 pi minus 3,200 square centimeters. Or that is approximately equal to, compute natin, minus, and then round off to 2 decimal places. The answer is 1,826.55 square centimeters. So that is how we find the area of that draft leaf. Okay, that's all for today, my dear learners. So I hope you learn a lot from today's video lesson. So see you again in our next video lesson. Goodbye, everyone.